Alright guys, this question that we have here is a Chem 102 LASU past question that is under the topic stereochemistry. Under the topic stereochemistry, and it is testing our knowledge on the chiral center. Now, a chiral center, before we solve this particular question, let's look at what a chiral center is. A chiral center is simply also called chiral carbon. A chiral carbon must be attached to 4 different groups. That is, if we have a carbon like this, let's say for example we have a carbon like this, it must be attached to a 4 different groups. Let's say this one is attached to hydrogen, this one is the same carbon atom is attached to chlorine, the same carbon atom is attached to an R group, and the same carbon atom is attached to bromine. So this carbon here is a what? Chiral carbon, or also called what? Chiral center. So that's the basic idea in going about solving this particular problem. Now, this problem says that the chiral center in the organic compound above is A carbon 2. This is the compound here. A carbon 2, B carbon 1 and 2. That's carbon 1 and carbon 2. C carbon 2 and carbon 4, and D carbon 4. So how do you go about solving this question? Now, I said it earlier that a chiral center or chiral carbon must be attached to 4 different groups. Now, what we'll be doing is to check out each of the carbon atoms here and check if which one is attached to 4 different groups, and that carbon atom will be chiral center. Now let's go about solving it. Now the first thing, let's look at the carbon 1 here. Let's look at the carbon 1. If you look at the carbon 1, you will see that this carbon 1 it is attached to hydrogen and another hydrogen. See, if you just see that a carbon atom is attached to 2 identical groups, just know that that carbon atom is not a chiral center anymore, because it must be attached to 4 different groups. And you seeing that this same carbon 1 is attached to hydrogen and attached to another hydrogen, hence this one is not a chiral carbon. So that means C1, that's the carbon 1, is not a chiral carbon. Now let's move to carbon 2. For this carbon 2, it is attached to this carbon 2. Let's look critically. It is attached to hydrogen here. That's one group here, that's hydrogen. It is attached to chlorine here. That's another different group. Now if you check out, it is attached to C1, and this C1 is different from the C3 that it is attached to in this side. So now we can see that this is a chiral center because this carbon 2 is attached to carbon 1 and carbon 3, and this carbon 1 and carbon 3 are 2 different groups. Let's just look it in this concept. When we have, let's say we have the C2 here and it's attached to hydrogen up here, is attached to chlorine down here, and it's attached to, let's call this C3R2 and call this C1 R1. So we can clearly see that these are 4 different groups, hence making carbon 2 a chiral center. So we already have one chiral center like that, and we are looking for others too. Now let's go to the carbon 3. If you check out carbon 3 here, it is attached to hydrogen up here and it's attached to another hydrogen down here. Hence this can never be a chiral center or chiral carbon because it's already attached to 2 identical groups. Hence this makes carbon 3 not a chiral center, and carbon 2 is a chiral center. Now to the last carbon here, which is carbon 4. If you check it out very, very well, carbon 4 is attached to chlorine up here, a group chlorine, and is attached to something down here, which is the hydroxyl group. attached to the hydroxyl group down. That's the OH, which is the functional group for alcohol. Now you can clearly see that these two are different groups. Now if you check it out, it's attached to hydrogen at this extreme end, another different group going right. Now let's look at what it is attached to at this side. It's attached to carbon 3, or let's say, now if it is attached to carbon 3, that is, come here, let's say we have carbon 4 here, so it is attached to chlorine up here, it is attached to hydrogen, attached to OH, and attached to, let's call everything here out. So it is attached to 4 different groups. That is, carbon 4 is also what? A chiral carbon, or let's say a chiral center. So that's the basic idea here. So carbon 4 is a chiral center. Now to the question, they say what? The chiral center in the organic compound above is A, carbon 2. This is not the correct answer. Now B, carbon 1 and carbon 2. Now already from what we now this carbon 2 here is actually a chiral center, but this is not the correct answer because we still have option C, which states what? Carbon 2 and carbon 4. This is the best answer here. So that's why I say this is not the correct answer. Now carbon 1 and carbon 2. Carbon 1 is not a chiral center, making this option 2 incorrect. Now carbon 4, this is not also the correct answer because carbon 4 is not the only chiral center we have here. So that makes option C the correct answer. Watch out for more video.